Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 4 video on the chapter of direct and inverse proportion, where I will discuss about inverse variation, how two quantities x and y vary inversely. What is the relationship between the values of the quantities x and y when they vary inversely? So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 4 on the chapter of direct and inverse proportion on the topic of inverse variation. Okay, so I have prepared my rough notes. Uh, as you can see on the right hand side, I have my canvas where I have written some notes on the inverse proportion. The theoretical concept of inverse proportion is very less as it was for direct proportion. The main concept is to understand a lot of examples how the two quantities are varying inversely, and then and solve a lot of problems. So the theoretical concept is not much. So let's start. So what do we mean when we say that two quantities x and y vary inversely? So this is the symbol we use. So when we say two quantities x and y vary inversely, as you know from the previous discussion on the direct variation, that this symbol is for varies. This is the mathematical symbol to denote that two quantities varies with each other. Now, for direct variation, we used to write x varies directly with y. So this means x varies directly with y, or the quantities x and y are in direct variation. Now, to denote that the quantities x and y vary inversely or are in inverse proportion, we use instead of y we write 1 by y. That is, 1 by y is the inverse of y. So that is how we mean mathematically denote the fact that x and y vary inversely. Now what does it mean? So two quantities x and y are said to be in inverse proportion when we have the three conditions, not these three results when happen when so I mean, these three behaviors are observed when when you change the value of x. So since x and y are varying with each other, definitely if you change x, the y will change, and if you change y, x will change. Now, how specifically they are changing when they are in inverse proportion? So when you increase the value of x, the value of y will decrease. So I am using the symbol this to mean that when you are increasing the value of x. So if you increase x, the value of y will decrease. So I am to denote the fact that the value of y is decreasing, I am using this symbol, the downward arrow, the downward arrow, and to denote the fact that the value of x is increasing, I am using this upward arrow. So when x is increasing, y is decreasing, this also, and vice versa, meaning if you decrease the value of y, the value of x will increase. Now the second is that if you decrease the value of x, the y will increase, and vice versa, meaning if you increase the value of y, the value of x will decrease. So these two are the main concept. Now from these two concepts, from 1 and 2, it is observed or quite obvious that the value of x and y, that is xy, is a constant, will always be a constant, and it will be so. So this means that if you take some values of x and the corresponding values of y, then the product of the value of x and y is always the same constant. Meaning, so if x1, x2, x3 like this and y1, y2, y3 are corresponding values of quantity x and y. Now, by corresponding values of x and y, it means that when the value of x is x1, then the value of y is y1. Similarly, when the value of x is x2, the value of y is y2. Similarly, when the value of x is x3, the value of y is y3. So this is what it means, that x1, x2, x3 and similarly y1, y2, y3 are respectively the corresponding values of quantity x and y. In that case, we must have x1, y1 will be equal to x2, y2 will be equal to x3, y3, and all these values, that is the product of x1, y1 and x2, y2 and x3, y3 will be equal to the same constant, this k, where this k is known as the constant of variation or constant of proportion. So this is the concept about two quantities x and y when they vary inversely or when they are in inverse proportion or inverse variation. Now let's look at some examples where we see inverse proportion. I have considered very standard 4 examples. These are very standard 4 examples, even though there are very many other examples that you will come across when you will solve problems, a lot of problems from your books and also in this channel. Okay, so the first one is men, work and time. So by men we mean a number of men working for a work. Work is a certain amount of work, and the time is the time taken, usually the number of days to complete the work. Now, if the amount of work is kept constant, by amount of work you can consider, let's say a 1 kilometer road is being constructed. A 1 kilometer road is being constructed, that you can consider as an amount of work. So that 1 kilometer, the length of the road is kept constant. So if the amount of work is kept constant and we consider the quantity x to be the number of men required to complete that amount of work, and the quantity y to represent the number of days to complete that amount of work, then it is found that the quantity x and y will be inversely proportional to each other. That is x and y will be in inverse variation or inverse proportion, or x will vary inversely with y. So this is a very standard example. So please keep in mind that the amount of work is kept constant. Now I just give an example that the amount of work could be constructing a 1 kilometer road. Now, so that is a constant. Now the moment, so for the 1 kilometer constructing a 1 kilometer road, the constant of variation will be something, that is the product of the corresponding values of x and y, that is x1, y1, x2, y2. These two, all these values will be something. Now if you change the amount of work, let's say the work is to construct 10 kilometers of road, then the constant of variation will change. But for that 10 kilometer for constructing 10 kilometer length of a road, still the number of men to complete the work and the number of days to complete that work, they will be in inversely proportional. That is, their product will be a constant, but that constant will be different, since this time the amount of work is different. That is, this time the amount of work is to construct 10 kilometer of road. So the constant of variation will be different. Okay, the next example is distance, speed and time. So this is about a vehicle traveling a certain distance with a certain speed, and it is completing it is covering a certain distance in a certain time. So if the distance covered is kept constant, if the distance covered is kept constant, then if we consider the x to be the speed of the vehicle and y to be the time taken to cover the distance, that is the constant distance, then the variable, then the quantity x and y will be inversely proportional. That is, they will be in inverse proportion, which means that definitely you can understand if the distance to be covered is kept constant, the more the speed of the vehicle is, in lesser the time it will take to cover the distance. And obviously, if the speed is less, then the time taken will be more. Okay. The next example is men and provisions. Now, I exactly do not know what provisions mean. It might be food. That is, a certain number of men are engaged in doing some kind of work day by day. So they need some food for their survival. So men and provisions means that certain amount of food for a certain amount of food, a number of men can survive for a certain number of days. So if you consider that the provision, that is the amount of food, is constant, then obviously, and if you consider the x to be the number of men and y to be the number of days the provisions last, which means that x number of men, x number of men can survive for y number of days using that constant provisions. Then the quantity x and y will be in inverse variation, that is, x and y will vary inversely with each other. As you can understand, if the food is constant and the number of men is increased, then definitely the number of days the food will last will be less. And if the number of men is decreased, then definitely the number of days the food will last will be more, because since the number of see, it is all depending upon the consumption of food by a single man, so which is usually constant. So if the food is constant, then if there are more men, then definitely the food will last for lesser number of days. Okay. The next example is budget and articles bought. So if some person is having is having a budget and he or she is purchasing some articles. Now the articles, so now if the budget is kept constant, that is, the person has a fixed amount of money that he can use to purchase some articles, then in that case, if we consider the quantity x to be the number of articles bought and the quantity y to be the price of each article, then obviously the quantity x and y will be in inverse variation, because the budget is constant. So with the fixed amount of money, if the price of each article becomes more, definitely you will be able to purchase less number of articles. And if the price of articles gets reduced, then definitely you can purchase more number of articles. So okay, so these were 4 very standard examples of inverse proportion. Now let's quickly solve some standard and typical problems. Even though this problem, there are a lot of other variations of problem and more harder problems which we will cover in the homework problems. When I will provide homework problems, then we will cover. In this video, I will discuss a very relatively easier and straightforward questions. Okay. So the first question is the first question says that if x, so this symbol, as you can always remember that this means that x varies as 1 by y, means that the quantity x and y are in inverse proportion, that is, x and y varies inversely with each other, or you can say that xy will be a constant. So it is given that x and y are in inverse variation, and when the value of x is 30, when the value of y is 10, then find the value of x when y is 600. So it is a convention to solve the problems of proportion, that is direct and inverse proportion or variation, using a table. So what we do is you create a table, as we have discussed in the case of a direct variation. We have already solved homework problems number 1 on direct variation. There also we used table, and you will also see in the textbook tables are used to tabulate the data, given data in the problem, and solve the unknown. So we create a table of the two quantities x and y. We know that the quantity x and y vary inversely with each other. Now the first data is given that when y is 10, the value of x is 30. So this is the first corresponding values. Now it is asking what will be the value of x when y is 600. So when y is 600, what will be the value of x? So the question mark has to be filled in. So usually by convention we assume that when y is 600, let the value of x is x1. Now we use the fact since x and y are inversely proportional to each other, the product of all the corresponding values has to be equal, which is basically that constant value is the constant of variation. So we must have the product of the first corresponding value is 30 multiplied by 10. This must be equal to the product of the second corresponding values, that is x1 multiplied by 600. So from here we can easily solve for x1. So x1 will be 30 multiplied by 10 divided by 600. Okay, so this is equal to 2 cancels out, we are having half. So the value of x1 is half. As you can see, if you multiply half and 600, it will be 300, and also if you multiply the corresponding values of the first corresponding values, that is 30 and 10, it is 300. So in this case you can say that the constant of proportionality is 300, or the constant of not proportionality, the constant of variation or the constant of proportion is 300, as we have discussed. That when x and y, quantity x and y are inversely varies inversely with each other, then their product is a constant. That is the product of the corresponding the corresponding values of x and y, that is x1 y1 and x2 y2, x3 y3. They are all these values are same, which is a constant k, which is known as the constant of variation. So in this problem, the constant of variation k is 300. Okay. Let's see the problem number 2. So a table is given and there is some two unknown values x1 and y1. So x1 is a corresponding value of x and y1 is a corresponding value of y1 is a value of y and x1 is a value of x. So it is given that if x and y varies inversely, then find the values of x1 and y1 in the table given below. So we will apply the same concept, that the product of the corresponding values should be equal for all the corresponding values. That is the product of the x and y for all the data should be equal. That is, we must have 12 multiplied by 8 should be equal to x1 multiplied by 4 should be equal to 16 multiplied by y1. We must have this since the quantity x and y are varying inversely with each other. Now, so this implies 12 into 8 is 96, should be equal to 4x1 should be equal to 16y1. So from this we can easily find x1 to be equal to 96 by 4, which is equal to 24. So x1 is 24, and from these so also we have that 96 should be equal to 16y1. From here we can uh, find the value of y1 to be 96 divided by 16, which is equal to 6. So we have found the values. X1 is 24 and y1 is 6. Now, if I am doing any kind of calculation mistake in multiplication division, I am not really focusing in that. I am more focused in applying the concept correctly and solving the problem uh, using the correct concept. So, if I do mistakes, please ignore if I am doing any kind of calculation mistakes and my answers are coming out to be wrong. Okay. Okay. Let's do the problem number 3. Now, this is a little conceptual problem. So, it is given that x varies inversely with y. This means that the quantity x and y are varying inversely with each other. Then find whether the following quantities are inversely proportional or not. We have four parts. So, we have to check whether these two quantities are inversely these two quantities, that is the quantities are 2x and 3y. For this part the quantities are 1 by x and 1 by y. For this part the quantities are x square y, and for this part the quantities are x plus y and y, and x plus 1 and y minus 1. So let's see, let's do 1. Now we have to check whether the quantity 2x and 3y are inversely proportional to each other or not. We can say that the quantity 2x and 3y are inversely proportional to each other only when their product, that is 2x and 3y, will be a constant. Now we know that since it is given that x, the quantity x and y varies inversely to each other, means we know that the product must be some constant. Let's say that constant be k. Okay, we will use this result that xy is equal to k, where k is a constant. Now to verify whether the quantity 2x and 3y are varying inversely with each other or not, we have to verify that their product is a constant. So their product is 2x multiplied by 3x, which is equal to 6xy, which is equal to 6k. Since we know that xy is equal to k, now 6k is a constant. 6k is a constant, as k is a constant. K is the constant of variation for the quantity x and y. So 6k obviously must also be a constant. Now it is a different constant. You can consider this to be 6k to be k1. So the product of 2x, the product of the quantity 2x and 3y is coming out to be a constant. Now this constant is k1, which is 6k, which is definitely a different constant. So for these two quantity, as you can see, for the quantity 2x and 3y, the constant of variation is 6k, where k is the constant of variation for the quantity x and y. So definitely these two we can say that, so this implies we can say that the quantity 2x varies inversely with the quantity 3y. Okay, So the quantity, the first one, the quantity 2x and 3y, they are inversely proportional to each other, or they are in inverse variation or proportion. Let's see part 2. So the quantities are 1 by x and 1 by y. So the concept is similar. We will try to see whether their product is a constant or not. So their product is 1 by x multiplied by 1 by y, which is equal to 1 by x y, which is equal to 1 by k, and this is a constant. Since k is a constant, k is a constant of variation for the quantity x and y, so 1 by k should also be a constant. So let's say this is constant k2. So we see that the product of the quantity 1 by x and 1 by y is a constant, and hence we can say that these two quantity vary, you can say vary inversely, vary inversely. Okay, so let's do part 3. The quantities are x square y and y. Okay. So the concept is similar. We will try to see whether their product, the product of the quantities are coming out to be any constant or not. So we see x square y multiplied by y is coming out to be x square y square, and this is equal to k square. Since xy is k, because where we have assumed k to be the constant of variation of the two quantities x and y is given to be two quantities that vary inversely with each other. So you can consider, so since k is a constant, obviously k square will also be a constant. You can consider this constant to be k3. So this is a constant. So we can see that the product of the two quantities x square y and y is a constant. So we can say that they vary inversely with each other. So x square y varies inversely, x square y varies inversely with y. Let's see part 4, x plus 1 and y minus 1. Let's see x plus 1, the quantities are x plus 1 and y minus 1. So we have to see whether the product is a constant or not. So we find the product 1, this is equal to xy plus 5 minus x minus 1. Now this is equal to k plus y minus 1, y minus x minus 1. So definitely this is not a constant, because this expression contains the quantity x and y, so not a constant. Now what will be a constant? A constant will be any expression that has any numbers that should not contain x and y, It can obviously contain the k, because k is the constant of variation for the quantity x and y. So we see that x plus 1 and y minus 1, their product is not coming out to be a constant, because their product is k plus y minus x minus 1, and we are having, so it is having the quantity y and x. So it is not a constant, and hence this implies we can say that x plus 1 is not inversely proportional to y minus 1. So I am using this symbol to mean that I use this symbol. This is my convention. It may not be a standard convention used in the books. So when I write this, I mean x and y are not in direct variation. Similarly, when I write this, I mean that x and y are not in inverse variation. Okay. So that was problem 3. Now let's solve some what problems. These are the real problems that probably you will be asked to solve. Okay, so there are how many problems left? Okay, so two more, three problems. Okay, so if 7 men can repair a road of certain length in 24 days, then in how many days will 12 men be able to repair the same road? So this is based on the concept of men, work and time. So what is work here? The work here is to repair a road of certain length. So the work is constant. The work is constant because it is saying that then in how many days will 12 men be able to repair the same road, that is the road of same length. Means this means that the amount of work is same. So if I consider x as the number of men required to repair the road and the quantity y to be number of days required to repair the road, then certainly we can say that x and y, these two quantities are vary inversely with each other, because since the amount of work is constant, if you increase the number of men, definitely more men will complete the work in less number of days, and less men will complete the same work in more number of days. So now so now we can quickly create a table of the data for the two quantities x and y. Now I have assumed the quantity x to be the number of men required to repair the road and y to be the number of days required to repair the road. This is you can consider the other way around. You can also consider x to be the number of days required to repair the road and y to be the number of men required to repair the road. It does not that will not make any difference. Okay, so now it is given that 7 men is repairing the road in 24 days. So 7 I will enter the data. The value of 7 will go for x and the value of 24 will go for y. Now it is asking in how many days will 12 men be able to repair the same road. So if the number of men, that is the value of x is 12, then what will be the value of y? That is the question is asking in how many days will 12 men be able to repair the same road. So basically it is asking if there is a value of if the value of x is 12, then what will be the value of y? So let's say the value of y will be y1. So essentially y1 will be the number of days required by 12 men to repair the road. So now I will apply the concept of inverse variation. So I must have the product of the corresponding values to be equal for all the set of values. That is, I must have 7 multiplied by 24 is equal to 12 multiplied by y1. So from here I get y1 is equal to 7 multiplied by 24 divided by 12. This is equal to 14. So 12 men will repair the same road in 14 days. Obviously, if 7 men is completing the road, is repairing the road in 24 days, then 12 men is more than 7. So 12 men will obviously repair the road in lesser number of days than 24. And so the answer is 14. Okay. Example 5. In a certain camp, there is provisions for 1600 participants for 60 days. Actually, 1200 people participated. Then for how many days will the provisions last? So this problem is based on men and provisions. So provisions is like a amount of food. So it is saying that in a camp there is a certain amount of food which is fixed, which will help, which is enough for 1600 participants to survive for 60 days. So the amount of food is constant, that by consuming that amount of food, 1600 participants can last can survive for 60 days. So it is asking, actually 1200 people participated, so then for how many days will the provisions last? So basically it is asking, if the number of participants is 1200, then using that same amount of provisions, for how many days the 1200 people will survive. So we can consider X to be the number of participants, and Y is number of days provisions means food lasts. That is, this means that the number of days provisions lasts means the number of days the participants can survive using the provision. So clearly we see that X will vary inversely with Y. X will vary inversely with Y, because the amount of food is constant. So if there are more number of participants, obviously more food will be consumed per day, and hence the food will last for less number of days. And if the number of participants is more, and if the number of participants is less, then less food will be consumed per day, and the number of days last will be more. So we have this. Now we can create the table of the quantity X and Y. So X we have considered to be the number of participants, and Y to be the number of days the provisions last. So it is given for the first data, for the first corresponding values, we have there is provisions for 1600 participants for 60 days. So 1600 will be the value of X, and 60 days, 60 will be the value of Y. Now it is asking, actually 1200 people participated, then for how many days will the provisions last? So basically it is asking what will be the value of Y when value of X is 1200. So let the value of Y be Y1, that is, we are assuming that Y1 to be the number of days the provisions will last when the number of participants is 1200. So now we should have 1600 multiplied by 60 should be equal to 1200 multiplied by Y1. So this implies Y1 is equal to 1600 multiplied by 60 divided by 1200. So this is 5 equal to 80. So 80 days. So definitely 1200 is less than 1600. So when the number of participants is less amount of food will be consumed per day, and hence the number of days the food will last will be more. So we are having more number of days. 80 is more than 60. Okay. Let's do problem number 6. A car travels from station A to B at an average speed of 57.4 km per hour in 3.5 hours. What should be the speed of the car to return from station B to A in 2.8 hours? So as you can see, the distance covered, the distance from A to B is constant, it is not changing. So the distance from A to B is same as the distance from B to A. So the car is traveling the same distance. So the distance is the distance covered is constant, but the speed is changing. The speed is changing and the time is changing. So if we consider X to be the speed of car and y to be the time taken. Obviously, the speed of cars will be in kilometer per hour, and let's say the quantity y represent the time taken to cover distance between A and B. A and B, this is in hour. So we can create the table of the quantity x and y. So first it is said that a car travels from station A to B at an average speed of 57.4 kilometer per hour. So 57.4 kilometer is the speed. So we can have the value of 57.4 for x, and the corresponding value of y will be 3.5 hours. So we have these corresponding values. Now it is asking what should be the speed of the car to return from station B to A in 2.5 hours. That basically it is asking what should be the speed to cover the distance between the two stations in 2.8 hours. So let that speed be x1, and it is let that speed be x1 such that it is covering the distance in 2.8 hours. So we have to find x1. So clearly we know that since the quantities x and y are varying inversely with each other, we must have the product of the corresponding values must be equal. So we must have 57.4 multiplied by 3.5 should be equal to x1 multiplied by 2.8. So this implies x1 is equal to 57.4 multiplied by 3.5 divided by 2.8. So if you convert all the decimals to fractions, we get this to be equal to 574 by 10 multiplied by 35 by 10 multiplied by 10 by 28. 2.8 is to 28 by 10, and the 10 will go in the numerator. So we have this. So 10 cancels out, and 7 divides 28 with 4, 7 divides 35 with 5, 5 divides 10 with 2, and 4 divides 574 with 1. No. 2 divides 574 with 4, 8 and 7. Okay, so this is coming out to be a fraction. This is equal to 287 by 4. Remember, the values of x are in kilometer per hour. So this is actually kilometer per hour. So this is equal to 7 1 8 no, not 8, 7 5 kilometer per hour. Now you can also from common sense check whether your answers are coming or not. Now since the distance covered is constant, if the car travels at a higher speed, the time taken to cover the distance will be less, and if the car is traveling at a lesser speed, at a slow speed, then the time taken to cover the distance will be more. In the case of when the car was traveling at 57.4 km per hour, the time taken was 3.5 hours. And if the x1, if the car is traveling at 71.75 km per hour, the time should be ideally less, which is 2.8. So our answer is correct. Now I am not sure whether 71.75 is the exact answer or not, because I could be making some calculation mistake. I am not really focusing in that. So that was all regarding the illustrative examples. So this brings to an end in the discussion of indirect inverse variation, or when two quantities x and y varies inversely with each other, and some problems to uh, illustrate how we apply the concept to solve the problems. Uh, so if this video was beneficial, please like it, share it with your friends, and also support me by subscribing to my channel if you are not yet, and do not forget to press the bell icon so that you will be notified by my future videos. So I have completed all the concept part of this chapter, that is inverse and direct and inverse variation. The next I will in the next upcoming videos I will solve the the next exercise from the textbook of author RS Aggarwal, which is exercise 12b. After solving exercise 12b, I will solve the exercise 12c, which is objective questions based on both the concept of direct and inverse variation. So look out for those videos that are coming soon in this playlist. And also I will start parallelly solving 10 good problems on this chapter in the other playlist, that is Maths 8 Hot. So with this I will end this video. Thanks for watching, and until the next video, take care and bye.